Woohoo! Here we are for Math 60, Chapters 9 and 10 practice test. Woohoo! Yay! So Chapters 9 and 10 are just the last two chapters we cover. They don't really go together great. Chapter 9 is all about exponential form, logarithmic form, how they're interactive. And then Chapter 10 is all about graphing circles, which is pretty much completely different. Now, for this particular test, because it is online in Canvas, it doesn't really lend itself to graphing very well. So that is something this test will not test. It will not test whether or not you have the graphing skills. The last problem kind of gets close to it, but doesn't really. So keep that in mind as you go through this test. It's a good test for the material, but only for the non-graphing parts of it. Okay, woohoo! As you can see, I've got this lovely little manipulative to help us remember logarithmic form and exponential form. And you can write each in the other form. So, log base blue of yellow is purple. That corresponds to blue to the purple equals yellow. Blue to the purple equals yellow. Or if you have blue to the purple equals yellow, that corresponds to blue, log base blue of yellow equals purple. And since color doesn't work for everyone, I went ahead and used some numbers. Log base 2 of 16 is 4, corresponds with 2 to the 4th equals 16, which it does. Yay! So let's go ahead and take a look at each of these. There are two problems in the first problem because these problems are pretty fast. So the first couple of test questions actually are multiple part. And let me see if I can scooch this over a little because I'm not going to need my calculator for these. I'm not actually sure we'll need the calculator at all. Let's take a look. That's always a good idea. If the calculator is nearby, it's always close if you need it. So first part, part A, log base 5 of x squared equals 6. Now, what have I done? Well, I've intentionally complicated this a little bit because you've got an extra thing in there that you weren't expecting. The 5 is our base. The x squared is our yellow. It's our argument of log, and normally we're expecting a single object there, and in fact we got x squared, so that was unexpected, but we can roll with it. And then 6 is our answer. It's the purple one. So let's go ahead and rewrite this in exponential form. And remember, I do the arrow facing both directions to remind all of us that anything that's a logarithm can be written as an exponential expression. Anything that's exponential can be written as a logarithm. Okay, so I've got 5, start down low. With the logarithm, start down low and then cross the equal sign, 5 to the 6th, and then come back, equals x squared. So there's our blue, right, just like that. Raised to the purple equals the yellow. And in fact, the x squared just stays together the whole time. You don't have to split up the x and the squared in this particular case. And so let's take a look. Do we have 5 to the 6th equals x squared? And in fact, we do. Woohoo! And I didn't simplify this because it just said write it in exponential form, not write it in exponential form and then solve. You could solve for x, and then we could talk about what values of x would be acceptable. But that's not what this problem asks for. Okay, let's go ahead and look at number B. Now this one, instead of giving you too much, I've given you too little. Right? I've just written log, and if you're just looking at this, you're like, wait, where's the blue? And remember, if I just write log, then what I really have is common log. Log base 10 of 7 equals a. And that's the trick. That's the way to remember it. Now, if you're forgetful, like I am, which I am quite a lot, let me see if I can get this close enough so you can see. On your calculator, which is bringing a calculator into a test is pretty standard. Sorry about my thumb. I got very excited about an avocado and tried to take off my thumb with it. I didn't try to use my thumb to take the avocado. I didn't cut myself with an avocado, although that would be an interesting situation. So you notice that natural log, right above the natural log, it says e to the x. So that's how I remember, natural log is the one that's base e. And then up here, common log right there, it just says log. And then it says 10 to the x right there. That reminds you, oh, base 10. Okay, so calculator, fair game for all tests, in my class at least, and that can help you remember, oh, right, common log is log base 10. And now we've got the same setup. I mean, this is you know, early in the section, although fairly simple. There's not a lot going on, but it was a profound result, right? We're relating to apparently different fields, even though they're not really once you get to know it. So I've got 10 to the a equals 7. And so we look up here and I see 10 to the a equals 7 right there for our possible answers. Woohoo! Woohoo! Number 1's done. Yay! Okay, next up, stick that there where it can't hurt anyone. Number 2. Now, number 2 says something slightly different. It says evaluate, which means we're going to get an answer. We're not going to rewrite it. We're going to actually get an answer. So I'm going to keep this close by just in case it's still helpful. And let's go ahead and look here. I've got e to the natural log of w cubed. Now, there are a ton of things you can do with this. Hopefully, if you've studied the sections in chapter 9, you know that, for example, the 3 can go in lots of interesting places, and certainly we could rewrite this as e raised to the log base e of w cubed. But then I want to remind you, one of the properties of logarithms is if you raise e to the log base e, so you raise e to its logarithm, it's as if they cancel each other out. They don't, not quite in the way we're used to canceling, but when you raise e to the power log base e of w cubed, you simply get w cubed. That's it. Now, you don't, in fact, get 3w, which is sitting right there winking at you. And I know some people are thinking, ooh, I'll bring the 3 down. But as soon as you bring the 3 down, then the canceling, the quote-unquote canceling, doesn't work anymore. So you got to leave the 3 up there so we get w cubed. If you're not sure about this, if you have your doubts, you can always, you know, have a calculator party. Woohoo! Let's hear for calculator parties. Okay. Second one, 3 log base c of c raised to the eth power. Oh my gosh, that just looks weird. I mean, honestly, if you wrote this and put it down in front of someone who hadn't studied exponents or logarithms, they'd be like, what is this even? It almost looks like an essay, or like you're trying to spell a word like log c. Or icky log, anyway. Okay, so what do we do? Well, the important part of this one is to realize that if you take log base c of c, then that will cancel out and you're left with whatever this power is. The other way to look at it is to realize, wait a minute, if this is c to the e, you can bring the e in front. And then you can realize that this part right here, this part, log base c of c, is 1. How many c's go multiply together go into c? Just 1. So what we have here is 3e times 1, which is just 3e, which is our first answer right there. Woohoo! Yay! And I'm going to draw a little dotted line here to remind everyone that it kind of, I mean, I think a lot of people say it cancels out. It is a logarithmic property, but I mean, just between us, you can say cancel it out. And steam won't come out of my ears much, possibly a little bit. I might just remind you. Okay, so, dun dun dun! Now, this one strikes me, and you'll have to let me know whether this is true, but when I was a student, this was the kind of problem that gave me nightmares. So, of course, trying to be a nice person, have decided to give you this problem just to make you miserable, right? No, I'm going to give you this problem, but then I'm going to show you how to do it. And I'm going to remind you that our friend Sharktopus is right here, and that we're going to be okay. We're going to be great. In fact, here, I'm going to do this. So I have an amazing partner who's worried that I make videos and forget to eat. So I was given a big bowl of blackberries. So you can look at the blackberries. Don't worry about the math. The math is fine. Ooh, blackberries. Okay, I wish I could share the blackberries with you, honestly. They are amazing. Okay, so we've got an equation, but all the x's are up in exponents. So what do you do when x's are up in the exponent? Well, that's the whole point of logarithms. So I want you to pick your favorite logarithm. Now, some people prefer natural log because it's only 2 letters. Some people like log because it's kind of round and friendly. I like log, so I'll probably use log, but you could use natural log, or you could even use your favorite base. Log base 5, log base 100, log base pi, whatever you'd like to use. My recommendation, though, and here's the hint, round your answer to the nearest tenth. These are not going to be answers we're going to be able to get in our heads, so we're going to need a calculator. If you have a not very fancy calculator like this one's fairly old and fairly simple. I just happen to love the color, and I already put my name on it. I actually put my name on it. Ooh. So this is one of the calculators I have in the classroom when we're meeting in person. But you'll notice on mine, I only really have options to do log or natural log. So I'm going to stick to those two. However, if you have a fancy pants calculator, now what kind of a fancy pants calculator? Well, if you have one of these, which I don't usually use in the videos only because it's just kind of fancier than most people have, but there is a way to do log with different bases, I believe, on this one. I think. Well, other fancy ones have it. Perhaps not this one. I swear there is. I swear there's a way to do it. Let me see. Log, natural log. Oh, yep, there we go. If you click on the natural log key 3 times, you can choose your base. So any base that you can put in, you can use. So you could use your favorite base for this. So it's up to you. And I'm doing my best not to sing It's All About That Bass. About that bass. I don't know what the pun would be for no trouble, but okay, so pick your favorite logarithm. Again, I'm going to use that. I'm going to use common log. Log of 2 to the x plus 1 equals log of 5 to the x. So basically, if these two things are equal, then their logarithms must be equal because logarithm is 1 to 1. The other consideration is that an exponential expression won't be negative. 2 to some power won't turn negative. And remember, logarithms, you can't take the logarithm of a negative number. So as long as these two things are positive, not 0, and they're equal, then we can use the logarithms. And now what is the point of this? Because now we've gone out of the frying pan into the fire. This just looks like, oh my gosh, 100 times more complicated, except remember, exponents come flying down. So I've got x plus 1 times log of 2 equals x times log of 5. And this was the whole point of using logarithms, because we can pull the x's down out of the exponent. Now, we still got a mess, so let's work together. Okay, no panicking. Remember, beautiful blueberries. Think summer, think delicious fruits, think happy thoughts. And let's go ahead and I'm going to multiply this out. x times log of 2 plus 1 times log of 2, right? So I'm just multiplying out to the right, equals x times log of 5. Now, believe it or not, this is the variable, right? So this is some number times x, this is some number times x, and this is just a number. So I'm going to move this over here, and I'm going to move this over here. First, I'm going to write it nicely. So x log of 2 plus, this is just 1 time, so I'm just going to write log of 2, equals x log of 5. Now, if you had one of those fancy calculators and you had chosen to use log base 2 or log base 5, this would be a lot easier. In fact, if you had chosen log base 2, you'd be almost all the way done at this point. Okay, so I'm going to subtract log of 2 from both sides. So I've got x log of 2 equals x log of 5 minus log of 2. At this point, you might be tired of the word log. I'm starting to forget what it means. I've said it too many times. X log of 5. Okay, so I've moved all the terms and I've basically run out of space, but this is x log of 2 minus x log of 5 equals the opposite of log of 2. Okay, now let me get some paper. And let's continue this problem. So let me copy it over. X log of 2 minus x log of 5 equals the opposite of the log of 2. Okay. Believe it or not, we're really close. Factor out the x. I've got log of 2 minus log of 5 equals the opposite of log of 2. Now, the trick here is to remember what's a number. This is a number. It's not a pretty number. I mean, you may think it's gorgeous. I don't know. It's certainly not a terminating decimal, right? Log of 2 is going to be something complicated that goes on for a long time. Log of 5, ditto. So subtracting these two, this is a job for our calculator, but this is still a number. So I'm going to divide both sides by that number. One of the most reassuring parts of math is not the blackberries, although they're pretty reassuring right now, is that the basic rules continue to work even when things get complicated. So if I've got a constant times x, what do? I divide both sides by that constant, even if it's gross. So over here, I get just x, and over here, I get the opposite of log of 2 all over log of 2 minus log of 5. Now we bring in the calculator. And I know some of you are looking at this going, wait a minute, I'm thinking of the properties of logs. That is awesome. Definitely be thinking about the properties of logs. But off the top of my head, I don't think it would simplify the problem. We could certainly play with the laws of logarithms, you know, like when you're subtracting logarithms or, you know, all that fun stuff. But I'm not going to worry about it here. I think I'm just going to go straight to the calculator. So, okay, I've got, now remember for the opposite, either in your head change the sign, or else remember you have to use this minus sign, not that minus sign, the subtraction. This is the opposite. Okay, the opposite of logarithm of 2. Now, the other thing to keep in mind is some calculators, notice right there, it started parenthesis. If I'm not careful, I need to finish this, so I need to do that. If I don't close the parenthesis, everything's going to get sucked into that top logarithm. So you get a couple options. Either you can hit equals, and that will make sure it doesn't get sucked in, or else you close the parenthesis. Okay, I'm going to go ahead and throw caution to the wind and just go ahead and divide. So I'm going to divide. Now these two are in the denominator, parentheses, so I'll need a parenthesis. Then log of 2. Make sure all of your logarithms are the same base. So I'm using common log. I'm going to close this one. So see, it's going to be a ton of parentheses running around. I'm going to subtract log of 5, close the parenthesis, and then close the bigger parenthesis. Cross my fingers. And it looks like I get 0.7564707797, some other numbers. And as I recall, let me pull this down so you guys can see, round your answer to the nearest tenth. So I'm going to go ahead and wiggle my equal sign, and I'm going to round it to 0.76. Which is, yay, it's the last one, right next to the blackberries that will save us. Woohoo! Okay, that's number 3. Woohoo! Not too bad. Remember, this is the last 2 sections in the book, so they're probably going to be pretty sophisticated. So pat yourself on the head a little bit for being amazing. You guys are getting through really sophisticated, really cool, different, interesting math. Okay. 2 more problems. We can do this. So, this problem, I've already got logarithms. So remember, in the previous problem, there were no logarithms, but to pull the x's out, we applied logarithms. Now in this problem, we already have logarithms. Now when you already have logarithms, if it's a simple logarithm, a single logarithm, you can use exponential form, like we did in like the first problem, second problem to try to deal with that. But in this one, there's no hope because we've got 2 logarithms. So if we've got logarithms together, the first thing to check is, do they have the same base? And the answer is they will, because in order to use the methods, we know they have to have them, but just double check. Yes. Okay, they're both base log. Remember, logarithm means log base 10, common log. Woohoo. So if they are the same base, let's use the law or the properties of logarithms that say if I have log of A plus log of B, that's equal to the logarithm of A times B. We just add them together, right? This has to do with the fact that logarithms and exponentials are like besties. So if you add them, you're actually multiplying. So, okay, so in other words, log of x plus log of x plus 48 is equal to log of x times x. Ooh, I caught myself. Thank you. I felt a disturbance, as if thousands of voices all said, "No, Miss Saunders, it's a minus," all at once, even though that's in the future. Brilliant. You guys sent me such a strong message. I could feel it back here in the past when I'm recording this. Nicely done. Thank you, thank you. So we can take these 2 and multiply them together as a single logarithm. And that whole thing is still equal to 2. So now we have an equation. I know you're thinking, well, great. We rewrote this. What's the point? Well, the point is that here with 2 logarithms, we're kind of sunk. So we move things around. We managed to get to 1 logarithm. If we have a single logarithm, if I have log of x times x minus 48 equals, 2, sorry, I was getting excited doing the next step, then I can rewrite that in exponential form because there's a single logarithm. A single logarithm means exponential form. And remember, this is log base 10. So I've got 10 squared equals x times the quantity x minus 48. So in other words, okay, this is one of those problems where it starts out and you think you're doing a logarithm problem, and then pretty soon you're actually working with the quadratic formula. 100 equals x squared minus 48x subtract 100. And in fact, this doesn't have to be the quadratic formula, x squared minus 48x minus 100. If you can factor this, and I'm going to say I can factor this. I don't know if you feel comfortable factoring it, awesome. If you're like, nah, my brain is toast with that first problem, that second problem, my brain is gone, that's fine. Sorry, Sharktopus. What you could do is you can also use the quadratic formula. So use the quadratic formula or use factoring, your choice. And let's see. Now, I happen to have written this problem, so I've already thought through it. But let's think through it. I need two numbers which when multiplied give me negative 100, but when added give me negative 48. And then I'm like, oh, wait a minute. How about negative 50 and positive 2? And I know you're all like, wait a minute, you wrote it. That's how you know. And the answer is yes. You can use the AC method. You can use trial and error. You can use the quadratic formula. You can use the X method. Where is it? There's the X method. Dun, dun, dun. A bunch of different ways to do it. So you're welcome to use whatever method you prefer. And we're basically just factoring now. And this is part of, some people have asked, is this what the rest of math is? And the answer is yes. The rest of math is you learn one new concept, and then we kind of mix everything together, and then you solve a bunch of problems that involve all the techniques you know. And then you learn a little bit more, and then you solve a bunch of problems. And the problems get harder because it takes longer to solve them because you have multiple steps. So this one you had to know logarithms, and now you have to know how to use either the zero property or the quadratic formula. But you do, which amazing. Pat yourself on the back or the head. Pat your brain if it doesn't hurt too much. Wash your hands first, obviously. Okay, so I've got this set up so I know x minus 50 equals 0 or x plus 2 equals 0. And I know you all are like, oh my gosh, do we have to do this? And the answer is I would recommend it only because it's really easy when things seem to get simple. If your brain is really tired from doing a bunch of steps, your brain is more prone to making mistakes. So x equals 50 or negative 2. And we look back here and we see, oh, no problem, it's right there. And then I'm going to say, I feel like I should say, technical difficulties, except it isn't really, it's mathematical difficulties. So what's wrong? Why can't I just circle the answer? And the answer is you can't, because you should always check. Always check. I know, I hated checking as a student. I'm not terribly fond of it as a teacher. It feels like it's just like, it's one more step. And we just finished. Okay, so let's look, where's the original problem? The original problem's right there. It was log of x plus log of x minus 48 equals 2. Okay, so let's see. This would be log of, so if x equals 50, log of 50 plus log of 50 minus 48, does that equal 2? So this is log of 50 plus log of 2. Okay. I can use my calculator, or I can use, my rules of logarithms, which would give me 100 here, and then I could go forward. So let's see, log of 50 plus log of 2 is equal to 2. Yay! Log, let's try x equals negative 2. log of negative 2 plus log of negative 2 minus 48. Does that equal 2? So that's log of negative 2 plus log of negative 50. And then I go ahead with my tired brain and I say log of negative 2 plus log of negative 48. And then it tells me this. And now that you know these words, hopefully you recognize the calculator is actually not just being a pain. The calculator's trying to help you out. The calculator during your test is going, psst, psst, hey, let me help you out here. So domain error means you've put something into logarithm that logarithm can't have. And why is that? Well, it's something that people miss because when you're reading through, you get all excited about the really fun, juicy stuff, and you miss the details. And the details are you can't take the log of a negative number. So we have to go back in, and I have to, with my red pen of destiny, cross out the negative 2. Okay, so let's go back and let's see. Now we appreciate, oh, how mean I was. Look at all these options. So the answer is it's just x equals 50, not x equals negative 2. Now, why does this happen? Well, because by the time we got here, when we were actually solving it, there were no logarithms anymore. And so we had asked algebra to solve this problem. These are both answers to this problem. However, they are not both answers to this. So that happens sometimes. Always, always check. Speaking of checking, I believe we are on the last problem. Oh my goodness. Oh, yay. Okay. So we're going to, I need that Foley of a needle scratching across a record. We're changing directions. We're suddenly in chapter 10, and this is circles. So I've got x squared plus 4x plus y squared minus 8y equals negative 11. And I need to put this into my HK form, right? So what does that mean? That means I want to put it into x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared form. So that is our standard general form for a circle. That's what we're aiming for. This one, the downside is it's completing the square. The upside is it is always the exact same thing. So let's go through it. Plus, you get really good at completing the square. X squared plus 4x, and then you leave a space. Plus y squared, pardon me for just a moment. Let me see if I can do this. Sorry about that. That was very exciting, wasn't it? I've got y squared minus 8y, and then a space, and then equals negative 11. So there are a couple ways to do this. Completing the square has a lot of different sort of style issues. So, but what I'm going to do here is I'm going to take a look, find the x. Remember, we take half of that coefficient. Half of 4 is 2. And then whatever we get there, we square it. It's kind of funny, we get back to 4. And then we put this number in this spot. So it becomes x squared plus 4x plus 4. But remember, we can't just do that on one side, so I have to add it to both sides, right? So this 4 goes right in there in that space, and it also goes over here. So I balance the equation by adding it on both sides. Next up, minus 8. So I take 1/2 of -8, and that's -4. And then -4, the quantity squared is 16, and that's what I need to add in here. This is, remember, we're completing the square, so we're adding in numbers so that we can get a square. Okay, so, and then also recall, let's see, do I have enough colors to do it fancy style? I do. So remember that whatever number is there tells you what your perfect square is. So there is, if you follow all the steps and try not to race through it, this first number you get when you multiply by 1/2, that's the number you get in. That's your H and your K right there. And then over on the other side, I've just got to add all these together, and I think I get 9. Okay, so remember how we do this. Now, it's x minus h and y minus k. So h is -2. So it's not quite, this doesn't quite give us h, it gives us the opposite of h. And then 4, it's y minus k, so y minus 4, k is 4. And then r squared is 9, r is 3. So I got h is -2, k is 4, and r is 3. Woohoo! What do you guys think? Kind of, sort of. It's the closest I could get to graphing without graphing, because Canvas tests don't allow for graphing, unfortunately. And that's it. You're done. Woohoo! Congratulations, you made it. Woohoo! Yay, last practice test of the semester. So, take a break, rest your eyes, go look at something outside that's green, maybe pet an animal, get some delicious, delicious fruit, or, vegetables, or whatever's good for you, some water, little sunshine, even if you are a creature of darkness like I am. And, know that you're awesome and amazing, and, woohoo, and math on.